And how many valence electrons does it have?
2.
2. So its electron dot would look like that. Rubidium, atomic number 37. It's argon. And then, actually, krypton. Yeah, I'm sorry. I don't have an answer key in front of me. It's krypton, yep. Okay, it's in group 1. So how many valence electrons?
1.
Good. And this was rubidium. Only 1 dot. And then iodine is krypton, and that's a halogen. So 5s2, 4d10. Just like all the rest of the halogens, how many valence electrons? 7. So this was iodine. 1, 2, 3, 4, 5, 6. And where you put the dots doesn't really make a difference. Any place as long as you have 7 would be fine. Okay. The selenium, you have to get the atomic number, the number of electrons, the number of neutrons. So the number of protons, electrons, and the atomic number, A, B, and D, are all 34. A, B, and D. The atomic weight, E, is 78.96. The mass number, F, would be 79. To get the number of neutrons, it's 79 minus 34, 45. It's in period 4, group 6. So that means it has 6 valence electrons and the valence level is 4. Calcium is atomic number 20, so that's the protons and the electrons. The numbers on the test are the mass numbers. And to get the number of neutrons, it's the difference between the atomic number and the mass number. So it's 20, 21, and 22 respectively. All right, any questions on this? Yep. What group is this in? Selenium not in group 8. It's not in group 8. Selenium's right here. Okay. I got some minor these up.
This is
Thank you, thank you. Thank you. Okay. Moving on. Let's actually before we get to this stuff, let's review the handout that you should have. This one here. So please take that out. I got another handout for you. Okay, and so this is the lab we're going to do, but I just wanted to give you this. So here's a periodic table, and here's a list of the common polyatomics, polyatomic ions. You'll be given this. So you'll be given this. This is what you're going to be given on the next test. Okay? So you'll have a periodic table and a list of common polyatomic ions. So before we get to the formula equation, let's take a...
Are you going to give us the types
No.
of reaction?
So you need to know the types of reactions.
Okay.
So the things that you need to know would be, well, someone tell me, what do you need to know? Types of reactions is one. Because that allows you to figure out what the products are. What else do you need to know?
Charges?
Yeah, charges of the monatomic ions. So you need to be able to look at the periodic table and tell me what the charge of an ion is, and let's review that. What's the charge of an iodine ion in group 7?
-1.
-1. Remember? It has 7 valence electrons. When bonding occurs, what type of electron configuration do the atoms try to achieve? What type of electron configuration? How many valence electrons do they need to get?
8.
8. So if it has 7, it would need to do what? Gain 1. So what would the charge be? If you have 7 valence electrons like the halogens in group 7, they would gain 1. What would the charge be? Remember, electrons are negatively charged. Let me repeat this. Elements in group 7 have how many valence electrons? 7. How many more do they need to get an octet?
1.
1. And if you gain 1 electron, which is negatively charged, what's the charge of the ion?
8.
No,
Negative?
-1. When you gain an electron, you charge, atoms are neutrally charged. Protons equals electrons. When you gain an electron, your charge, each time you gain an electron, your charge goes down by 1, because you're picking up a negative. So all the elements in group 7 have a -1 charge when they form ions. How about the elements in group 6, like oxygen and sulfur?
-2.
They would be -2. They gain 2 electrons. How about the elements in group 5, with 5 valence electrons?
-3.
-3. Okay, how about the elements in group 4?
-4.
Well, typically they don't lose, so, let's go back. The ones at the bottom, like tin and lead, are metals, so they are going to lose. So what would the charge be? If you lose 4, remember if you're in your group 4,
Plus
like
4.
tin plus 4. The other ones could, if you said it's +4 or -4, it doesn't make a difference because it's 4. When we use the ion charge method, we get rid of the signs, and carbon just forms covalent bonds, so it's not going to be ions anyway. It will be 4 bonds that will always form. So the number is 4. How about the elements in group 3 that have 3 valence electrons? What would they do to get an octet?
2.
Like aluminum, if it has 3 valence electrons, what would it need to do?
Gain.
Not gain 5, they're metals.
Under 4?
It's under 4.
Under 4.
So what would they do?
Lose.
Lose 3. So what would the charge be? +3. When you lose, it's positive. Because you're losing a negative, right? The transition elements in the D sublevel block, most of them, what's the best guess? Because they all have how many valence electrons?
2.
2. So the best guess would be
+2.
+2. Some of them could be +1, like silver is irregular. It only has 1 valence electron. And then some of them are polyvalent. Like iron. There's iron 2 and iron 3. Iron 2 is called ferrous. Iron 3 is called ferric. Well, we don't need to know those names, but you might want to be familiar with them. But if it's iron 2 and it has a Roman numeral 2 after it, what's the charge? +2. If it's iron 3, which is called ferric, what would the charge be? +3. If it's copper 1, +1. Okay, the alkaline earth metals in group 2, like calcium and strontium and barium and magnesium with 2 valence electrons. What would their charge be? +2. The alkali metals in group 1, like lithium and sodium, with 1 valence electron, what would their charge be?
+1.
+1. So you need to know the charges of the, and I'll say monatomic ions. Monatomic. The charges of the ions in the periodic table. You'll need to know that, just like we did. The polyatomic ions, I will provide you. I'll provide you this list of polyatomic ions. Again, we used to have students memorize them. We don't do that anymore. But you should look them over and become familiar with them. All right, so you should know that nitrate or chlorate, those are polyatomic oxyanions. Anions that contain oxygen and another nonmetal, and you would just look them up. Okay? So just look them up. So you need to know the monatomic ions and the types of reactions. And so on this handout here, what you should be able to do is, if you're given the formula of a compound, write the name, and if you're given a name, and write the formula. Right? But at the top it says, name the following ionic compounds. I'm not going to say name the following ionic compounds. You should be able to figure out if they're ionic. How do we know that all of these ones in the top are ionic compounds? Because they have what?
No parentheses.
Okay, if they have parentheses, what does that indicate? They're polyatomic ions. If they're ions, what type of bond? Ionic. What's another way you can tell? They all do happen to have parentheses, but they would have what? A metal and a nonmetal. A common cation, a common anion. Metals form common cations. So you can tell that these are ionic because they're common ions. Metals form cations, nonmetals form anions, and then we have the group of polyatomic ions. So those are ionic. And we just name the ions. Okay? The second group, how do we know those are binary covalent compounds? Two nonmetals. Two nonmetals would be a binary covalent compound. Okay? The third part, write the formula for the following ionic compounds. How do we write formulas for ionic compounds? What's the method we use? You crisscross the charges. That's called the ion charge method. And then the last part, write the formulas for each of the binary covalent compounds. How do we write the formulas?
By trying.
Yeah, by the prefixes. The prefixes tell you how many of each they have. So you need to know the prefixes. And I'll just put 1 through 5. The book has 1 through 10, but I'll only go up to 5. Mono, di, tri, tetra, penta. Okay, so let's take a look at a couple of these here. In fact, I'll let you remember, you should have tried this. If you didn't, make sure you do it for next time we have class.
Can you do 2 and 5?
The answers are on the back, okay? On the top one?
Yes.
Let's do 2, okay? Okay, so this is number 2. We have to name it. It's an ionic compound. What is the name of this compound? We just named the ions. What's Mg? Magnesium. What's NO3? Nitrate. That's it.
But you said you crisscross them?
No, you crisscross them and get the formulas. If you had this and you wanted to do the reverse, I'll go through that. So here we had a name, we had the formula. This is an ionic compound. We just named the ions. Magnesium is Mg is magnesium, NO3 is nitrate. You don't have to say dinitrate, you're not supposed to. If you did, I probably wouldn't mark it wrong because some people sometimes use those. Those prefixes are used for the covalent compounds. Magnesium and nitrate, this is the only ratio. It's always a 1 to 2 ratio. So you don't have to use the prefixes monos and dis for these ionic compounds. You just name the ions. So if I give you this name, if I give you the formula magnesium and nitrate ions, it's called magnesium nitrate. If we did the reverse, if you were given magnesium nitrate and you had to get the formula, that's when you use the ion charge method. What's the charge of magnesium?
+1.
Look at the periodic table.
+2.
It's +2. Mg is +2. Nitrate. What do we do for nitrate? We look at the list of common polyatomic ions.
-1.
Yep, it's, nitrate is NO3, and the charge of the nitrate ion is what? -1. So we put this in parentheses, and we treat this as one whole thing. So we never change the formula of the nitrate. This whole group of atoms acts like a single atom. It has a -1 charge. So this whole group gains an electron. Magnesium loses 2. In order for the magnesium to lose its 2 electrons, how many nitrates are we going to need? 2, because each one gains 1. You don't even have to think about it. Just get rid of the signs. The 1 goes there, and we don't write 1s in formulas. And the 2 goes there, and then we end up with MgNO3 taken twice. So that's where we crisscross. That's the ion charge method. It allows us to get the formula of an ionic compound. You just crisscross the charges, and put them down. And so in the formula, we just have symbols and subscripts and parentheses as needed around the polyatomic ions. And just always put a polyatomic ion in parentheses. It just allows you to not make mistakes. Does anyone have any questions on that?
Is that number 2?
This was number 2.
Alright.
Magnesium nitrate. Number 2, you were given the formula, you wrote the name, but we did the reverse as well, just for practice. Because those are the 2 questions. I'm going to give you this, you write that. I'm going to give you this, or you write that.
What's called the process?
This is called the ion charge method. It's a little trick that allows us to get the formulas. Okay? Now, the next part ends up even easier. The covalent ones are even easier. So if you had CCl4, carbon is a nonmetal, chlorine is a nonmetal, 2 nonmetals, so we use the prefixes. So there's nothing to switch, right? You have the formula to write the name, now we have to use the prefixes. So how do we name this? What should we do?
Carbon.
Yep, we can call it carbon, or if the first one, you can say mono, or you can just drop it if the first one only has 1. So I'll put the mono in just for now. 1 carbon and 4 chlorine. So what would we say for 4 chlorines?
Tetrachloride.
Tetrachloride. One carbon, mono, carbon. 4 chlorines, tetrachloride.
So mono means 1.
Mono means 1.
Tetra means 4.
4, yep. Mono is 1, so the prefixes are mono, di, tri, tetra, and penta. 1, 2, 3, 4, 5. Mono, di, tri, tetra, and penta. Okay. So if I gave you the name monocarbon tetrachloride, how do you get the formula? Mono means what? 1 carbon. Tetrachloride means 4 chlorines. CCl4. Given 1, write the other. Given the other, right? I'll give you one of them, the name of the formula, and you write the other one.
Give us 10 of those.
What?
So give us 10 of those.
Yeah, those are easy. You should know if you get any of those wrong. I mean, okay, and so that's half of the test. And then the other half is the knowing the types of reactions. You need to know the types of reactions. Oh, there's one more thing you should need to know. Remember the 7 special elements? What were they called?
Diatomic.
Diatomics. You should know the 7 diatomics. And so when you see those elements by themselves, like oxygen, right? What are we going to do for oxygen? We're not going to write O. What are we going to write?
O2.
O2, because that's how it naturally exists. And so the 7 diatomics, and we'll list them on the board. Remember, I gave you a little trick to help you remember. Which element do you want to start with? Number 7. N2, O2, F2, Cl2, Br2, and I2. Start with number 7. It kind of makes the shape of a 7. And the other one is hydrogen. So any of these elements, when they're by themselves, that's how you have to write them. Right. So if you see those elements by themselves, hydrogen, you have to write H2. Oxygen, you have to write O2. If I said chlorine gas reacted with something, you have to write Cl2, because that's how they naturally exist.
What are these called, the 7 what?
Diatomics. 7 diatomics.
Naturally exist.
What'd you say?
Did you say this is naturally?
That's how they naturally exist, yep. The oxygen in the air, oxygen naturally exists as O2. Nitrogen in the air naturally exists as N2. If we do a chemical reaction and we produce hydrogen gas, we're producing H2. So that's their elemental form. When they're in elemental form, when they exist as an element, this is how they naturally exist. So you'll need to know those. What?
What is 2 for?
You can hear.
I just understand what is 2 for.
What is 2 for?
Yeah.
2 atoms. Oxygen in the air we're breathing exists as O2. That's the formula for oxygen in the air. That's how it exists. It's an element that naturally exists as 2 atoms bonded together. Okay? Right? You've seen the formula for oxygen in the air, right? When you studied respiration, it's O2. That's just how oxygen exists. Okay? Okay. So the charges of the monatomic ions, the 5 prefixes, the 7 diatomics, and then you need to know the types of reactions. Composition, decomposition, single replacement, double replacement, and combustion. And so these are on the second page of the handout, and this handout was online. All right? That's the second page. You need to know those types. Because once you know those types, then if I give you the reactants, you can predict what's produced, the products. And so that brings us to this part right here. So let's do one of these together. Let's look at this one. Propane plus oxygen. Okay? What type of reaction is that? And yeah, let me I see some people a little bit struggling. Give me 1 second. Does anyone need a copy of the handout? One second, okay. Anyone else need a copy? So what type of reaction does propane plus oxygen look like?
Combustion?
Combustion. It's some type of hydrocarbon plus oxygen. And what do we do? We're burning it. This is combustion reaction. We're burning a hydrocarbon. We use hydrocarbons for fuel. The gas in the burners, methane and ethane, propane in your gas grill, butane in a lighter. Those are hydrocarbons. We burn them. That process is called combustion. And we burn them because those reactions are highly exothermic. What does exothermic mean?
Gives off a lot of heat.
Gives off a lot of heat. That's a good sign of reaction taking place. And so that's why we use them. So this is a combustion reaction. So in these simple combustion reactions, which, these compounds can get very, very complex, but these are low molecular weight hydrocarbons. So you always get the same two products. What do we get if we burn propane?
Carbon and water.
Carbon dioxide and water. It's always the same two products. It's a combustion reaction. We get carbon dioxide plus water. I'll give you the formulas of propane, of the hydrocarbons. Okay? Alright, so here's propane. So we've identified the type of reaction that allows us to predict the products. Now we can go from this word equation, propane plus oxygen yields carbon dioxide plus water, we can transform the entire word equation to a formula equation. Propane is C3H8. What should we write for oxygen?
O2.
O2. That's how oxygen exists. Yields carbon dioxide,
CO2.
CO2. No mono, you can drop it. Carbon dioxide means two oxygens, CO2, and then some of the compounds have their common names. Water is H2O, or you could say dihydrogen monoxide. Okay, we're just going to use water, H2O. And so we took the words, the names of the compounds and substances and elements, and transform them to their respective formulas. And now we have the formula equation, but there's one more thing. What's the last thing we need to do?
Balance.
Balance. You have to have the same number of each type on both sides. And to balance, what's the only thing we can do?
Add.
What are the numbers out in front called? The coefficients. You can only adjust the coefficients. You can't change any of the formulas. These are fixed. You can't change any of the formulas. You adjust the coefficients out in front, so you have the same number of each type of atom. And it doesn't make a difference really where you start. In these combustion reactions, you start with the carbons and hydrogens. How many carbons? 3. We can't start off with 3 and only end up with 1. We start off with 3, we're going to have to end up with 3. So what do we have to do? Yep. So what's the coefficient have to be? 3. Because that triples, that means 3 carbon dioxides. 1 CO2, another CO2, another CO2. That gives us 3 carbons and how many oxygens? 6. Okay? Alright, so 3 carbons, 3 carbons. We'll do the oxygens later. 8 hydrogens.
4.
2 hydrogens. So you need 4 waters. 4 waters, H2O, 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 2, 4, 6, 8. You multiply. 4 times 2, that gives you 8 hydrogens. And then how many oxygens does this give you?
4.
4. Okay? And so finally, the oxygens. How many oxygens here?
2.
2. How many on the product side?
10.
Don't say 6 or 4. How many?
10.
10. Because how many do we have here?
6.
6. We also have them here as well.
4.
So that's 4. So we have 6 and 4, we have 10. 2, 4, 6, 7, 8, 9, 10 oxygens. So what must this coefficient be? 5. And there's the correctly balanced formula equation.
Where did you get the 6, the 3, and the 2?
3 times 2, because there's 2 oxygens in carbon dioxide. And if you have 3 carbon dioxide, that's 2, 4, 6. You multiply. There's 3 triples the CO2, so it's multiplication. That's 6 oxygens there, and 4 waters. If each water has 1 oxygen, 4 waters has 4 oxygens. So 6 oxygens in carbon dioxide, and 4 in water gives us 10 oxygens. So we must have 5 of the O2 molecules to have 10 oxygens. Any questions on that? Anyone? Okay,
Why'd you choose the 3?
Why what?
Why'd you choose the 3
Why did I choose the?
on that carbon?
Because how many carbons does it have?
3. So
3.
you just take the first one from whatever?
You can.
That's what I mean, I wanna know, like, why?
Yeah, I took this as the first one. Yeah, when you do, now I'll give you hints as you go along, right? When you do these, and I think I mentioned it, when you do these combustion reactions, start with the carbons and hydrogens and do the oxygens at the end. You do the oxygens at the end because you have oxygen in multiple places. So you can't do it at the beginning because if you change one of them, so the oxygens will start you do those at the end and start with the carbons and hydrogens. As we do some of the other ones, I can give you some hints. When you do this one, sodium, you might, because it's all by itself, you might want to do that one at the end because that you can adjust whatever you want. But as we go through, I'll try to give you some hints, but you can start anywhere you want really. You'll get in the same spot. So you could have started with the hydrogens, you could have tried to start with the oxygens, but sometimes you have to go back and forth and then change something later on.
So you're just balancing each element?
We're balancing each element, that's exactly what we're doing.
So then,
Okay, try this one. Magnesium phosphate plus sodium.
the beginning.
Try that one. Magnesium phosphate plus sodium. Try that one. Finish the word equation, write the corresponding correctly balanced formula equation. what type of reaction does this look like, by the way?
Single replacement.
Single replacement. And so for a single replacement, you always have something like this. AX plus an element. And so remember, there are two types of single replacement. One where a metal replaces a metal, and one where a non-metal replaces a non-metal. So you have to look at this. Is sodium a metal or a non-metal?
No matter.
Metal. It's in group 1. It is a metal. So what will the sodium take the place of? The magnesium or the phosphate?
Magnesium.
Magnesium. So this is a metal. So the metal is going to take the place of the metal. Metals replace metals in single replacement. Non-metals replace non-metals. So this is a metal. It's going to take the place of the metal. So what would be produced?
Sodium phosphate
Sodium phosphate.
plus magnesium.
And now the magnesium is by itself. So that is a single replacement reaction. AX plus B yields BX plus A. Single replacement. Clear this out on the way. So that's the first thing you do because you need to know the types of reactions. This is a single replacement. Now you go through and write all the correct formulas and then balance. So write all the correct formulas and then balance. So let me help some people. So we're going to write formulas. We need the ion charge method. What's the charge of magnesium?
Plus 2.
Plus 2. It's in group 2.
Wait, why is it?
Magnesium is in group 2. It has a charge of plus 2. What is phosphate? Yeah, it's a polyatomic ion. It ends in ATE. You know it's going to be phosphorus and oxygen. You look it up. It's PO4 and the charge is -3.
Okay.
What about sodium? What's the charge of sodium?
+1.
+1. Okay, so there are all the ions. Now you should be able to figure this out. These you get from the periodic table. This one is given to you. Now you can write all the correct formulas using the ion charge method. And then balance. While you're working on that, I'll take attendance. Sion. Chuk May. Armenia. Rhonda. Jennifer. Paula. Maria. Edith. Ella.
Oh, yeah.
Giobel, S.A.,
I don't see.
Sydney, Greg, Hung, Elizabeth, Daphne, Maria Maria, Glendy, Gania. Okay, let's go through and finish this one up. What is the formula for magnesium phosphate?
Ma3.
Magnesium phosphate.
MgO3.
Mg3. PO42.
What's the formula for magnesium phosphate?
Mg3.
Mg3, parentheses,
PO4.
PO4,
2.
taken twice, yep. And how do we get that? Magnesium has a charge of +2, phosphate has a charge of -3. It's the ion charge method. Mg is +2, phosphate is PO4 -3. Get rid of the signs. 3 goes there, 2 goes there. The ion charge method. Want to ask a question?
No, because I don't even know how to phase.
Okay, let me go through this again. Do you know how we got the +2?
Yeah, it's on the chart.
This one you look up,
Mm-hmm.
right? That's on the chart as well. And this is like a little trick. You write the charges above them, get rid of the signs, and then crisscross them. That means you need 3 magnesiums for every 2 phosphates. That's it, just crisscross them. And so that allows you to get the formula. So this is the formula for magnesium phosphate. Okay, hopefully you're all set. All right, plus sodium, what should we write?
Na.
Just write the symbol, Na. It's not a diatomic, we just write Na. Now we need the formula for sodium phosphate. We use the ion charge method. What's the charge of sodium?
+1.
+1. What's the charge of phosphate? We already know it's -3. To get the formula, it's a little trick called the ion charge method. You get rid of the signs, and then these become the subscripts or the opposite ones. The 3 becomes a subscript over here, the 1 becomes a subscript over there. We don't write ones in formulas. We just write symbols and subscripts and parentheses as needed, and we don't write 1. If there's no subscript, it's understood to be 1. So the formula for sodium phosphate is Na3PO4 plus magnesium. What should we write? Mg. So there's all the correct formulas. Now, once we've written everything in its formula form, what do we have to do? Balance. So we adjust the coefficients out in front. I'm putting a little lines here to help prompt you. That's where we're going to change things. And so, let's see. And you can start anywhere. So you can start with the first one on the left and work your way over. Doesn't really make a difference. A lot of times, I might want to save this to the end because you can make it whatever you want. And you might want to save this to the end because you can make it whatever you want. And in this particular case, it's the phosphate that's going to influence the other ones. So you can start with the phosphate, but you can start anywhere. If you started with the phosphate, how many phosphates do you have?
2,
2. And how many phosphates do you have here?
1,
1. So what are we going to need to do?
2,
Put a 2 in front. Okay? That gives us 2 phosphates to balance these 2 phosphates. How many sodiums do we now have?
6,
6. 3 times 2 is 6, so what's going to have to go here?
6,
6. And then how about the magnesiums? How many magnesiums here?
3,
3. So what am I going to have to do? 3. And there's the correctly balanced form equation. Mg3PO4 taken twice plus 6 NAs yields 2 Na3PO4s plus 3 Mgs. And we're going to do it again. Okay, that's what the formula equation looks like. We are going to do it again. We're going to erase these. And let's do it just by starting with the magnesiums. How many magnesiums do you have? 3. So what would we do?
3,
Put a 3 here. How many phosphates do we have?
2,
2. How many phosphates?
1.
1. So what should we do?
2,
Put a 2 there. How many sodiums? 1. How many sodiums?
6,
6. 3 times 2 is 6. 6. So it doesn't make a difference where you start.
For some reason, I feel like, starting with in the beginning, it's much easier.
Yeah, wherever you want to start. Yeah, if you want to start at the beginning and just go right in order, and then I'll just double check at the end. Because sometimes when you change one thing, it changes something else in these compounds. So just double check at the end. But yeah, typically you start at the beginning. It's whatever works for you. Okay, try this one. Hydrogen chloride plus sodium hydroxide. Hydrogen chloride plus sodium hydroxide. I need to get some more. I'll be right back. About this. All right, you can work on that one. I'll be right back.
Girl, you should for real. Is it on here on the ship? No, that's cool. It's so fucking tough. November. Is it 17? I don't want to I swear. I hate this one. Once I do this compound, chemicals and this shit's November 17th. I will never take her advice again. Who's advice? Jeff? Yeah, it's like
Take a look at this one.
Each. That's the same thing, so I was calling.
Okay, what type of reaction does this look like?
Double replacement.
It's a double replacement. AX plus BY. So what would the products be?
Hydrogen.
AY plus BX. So what are the products?
Hydrogen.
Hydrogen. Oops. Sorry. Hydrogen.
Hydroxide.
Hydroxide. Sure. And the other one?
Sodium chloride.
Yep. Alright, so this might sound a little funny. Hydrogen hydroxide. Does anyone, what's the formula for hydrogen chloride?
HCl.
HCl. This is actually hydrochloric acid. So hydrochloric acid is HCl. It's hydrogen ions and chloride ions. Okay, but you call it, so an acid, anyone know what something an acid is? This has the hydrogen ion plus 1, the Cl ion minus 1, 1 to 1. An acid is something that produces the hydrogen ion. And so hydrochloric acid, hydrogen chloride is hydrochloric acid. Okay, and so that's one definition of an acid. Something that produces the hydrogen ion in solution. A hydrogen ion is really just a proton, because hydrogen has one proton, one electron. If it loses its one electron, it's just one proton. So that there's another definition. Sometimes acids are also called proton donors. But we'll just stick with hydrogen ions. It's something that produces, acids are something that produces the hydrogen ion solution. So you typically wouldn't see hydrogen chloride, you'd see it written as hydrochloric acid. Plus sodium hydroxide. What's the formula for sodium hydroxide?
NaOH.
NaOH. Na is plus 1, OH is minus 1, and this is a base, because the base produces the hydroxide ion in solution. And so this is a special type of double replacement reaction. It's an acid-base neutralization reaction. We have an acid, something that produces the hydrogen ion, with a base, something that is a hydroxide ion. And so what's produced? Hydrogen hydroxide. What's the formula for hydrogen hydroxide?
H2.
Yeah, H2O, it's water. And it always produces water. And the other one is called a salt. Ionic substances are referred to as salts. So it produces H2O, and then what's the formula for sodium chloride?
NaCl.
NaCl, okay? So this is a special type of double replacement reaction. It's an acid-base neutralization reaction. We have an acid plus a base yields a salt plus water. In any ionic substance is referred to as salt. There are special types, like acids are ionic substances that produce the hydrogen ion. Bases produce the hydroxide ion. And so, how about balancing this? Now, maybe it might be helpful if you write water as HOH, because there's your hydrogens to balance the hydrogens, there's the OHs to balance the OHs, but it doesn't make a difference. How many hydrogens do we have here? One. And then how many hydrogens do we have here? One. So we have a total of 2 hydrogens. 2 hydrogens. How many chlorines?
One.
One. How many sodiums? One. How many hydroxides? Well, now we already counted the hydrogen, so we count the oxygen. One oxygen. So we don't have to do anything? Nope, it's already balanced. This was real easy because what was all the charges of everything? One. So at the end, you're going to have 1 of everything. So if everything is plus or minus 1, it's going to be balanced at the end. Or you could say 1 hydrogen, 1 chlorine, 1 sodium, 1 OH, and 1 OH if you write it that way, but it doesn't make a difference. So this was a special type of double replacement reaction. All right, does anyone have any questions? So we are going to have a test next class, and it's going to look similar to this.
Not next week, but the week after.
We don't have a class next week, that's right. No class next week, it's the week after. It's going to look like this. Okay, it's going to look like this. So it's just given the formulas, write the names. Given the names, write the formulas. And then write the correctly balanced formula equations. Maybe a couple questions on ionic versus covalent bonds, like an ionic bond, what happens to the electrons? Transfer. A covalent bond, what happens to the electrons? What happens in the covalent bond? Sharing. Ionic bond formed between what types of elements? Covalent bond formed between 2 nonmetals. Okay? And then, but this is the bulk of the test. Given a formula, write the name. Given a name, write the formula. Okay? And so we are going to do a little bit more practice. And so what we are going to do is a lab. In some types of double replacement reactions, a precipitate is formed. A precipitate is an insoluble solid. What does it mean to be insoluble? Does not dissolve. What does soluble mean? Does dissolve. Okay? And so I've given you 2 handouts. Let me take you through the pre-lab question, because this is what you're going to do in the lab. Okay? So the pre-lab question says, basically you're going to write the correctly balanced formula. The pre-lab question says, for the reaction of aqueous solutions, what does it mean if something's aqueous? It's in water. All right, and that's when we're talking about solutions, we're talking about something dissolved in water, aqueous solution, something dissolved in water. For the reaction of aqueous solutions of silver nitrate and calcium chloride, write the complete molecular equation and identify the precipitate form. Why don't you try that one? So here's your reactants. Silver nitrate plus calcium chloride. Finish the word equation, write the correctly balanced formula equation. I'm doing the pre-dab question. All right, silver nitrate plus calcium chloride. Finish the word equation and write the correctly balanced formula equation. What did you say?
That's the same thing.
Yeah, you change the ending to IDE when it's in a compound. Okay, let's look at this one. So, what's the reaction we're looking at? Someone tell me?
Double replacement.
Yeah, the double replacement is one that forms a precipitate, an insoluble solid. So let's take a look at this. It's silver chloride, right? Remember, this was in its aqueous solution, it said, right? So we should put AQ after it means aqueous. If you see AQ after something, it means it's in a solution of water. Silver chloride is salt, dissolved in water, so we put AQ. If you see S after something, what would that mean in a reaction? Well, it actually means solid. Sometimes you'll see an arrow going down to indicate it's a precipitate, it's insoluble, it settles to the bottom. If you see an L after something, what does that mean? Liquid. If you see a G after something, what would that be? No one?
No idea.
Means it's a gas.
Oh, okay.
And gases bubble up, so sometimes you might see an arrow going up. Okay, so we took aqueous silver chloride.
Silver chloride, silver nitrate.
What? Oh, silver nitrate, I'm sorry.
Yeah.
And it's calcium chloride, right? So silver nitrate, thank you, plus calcium chloride. And this was aqueous as well. And so what would be produced? Double replacement. So what are the products?
Silver chloride,
Silver chloride.
Silver chloride
calcium nitrate.
plus calcium nitrate. And so
We have to put the AQ behind it all? or
The
we
products?
talk it now?
we don't know yet. I'm going to show you. So let's take a look at this reaction. Just test. So if we look at this reaction, this is what we'll see. So I'm going to add some silver nitrate. It's just a clear solution. These are all solutions in water. And when you do this, you only need like one drop. You don't need a lot. So there's the silver nitrate solution. It's silver nitrate dissolved in water. And now if I add the calcium chloride, that's also a solution. I'm going to add a couple drops. And what happened?
Fizz.
Oh, it turned,
Yeah.
lactose.
Yeah, it's a solid formed. Eventually, that solid will settle to the bottom. Whenever it gets cloudy, and you can see now, you can clearly see the solid form. Whenever it gets cloudy, that means a solid form. Okay? So when some reactions take place, like the combustion reactions, we saw propane plus oxygen. Why are those useful? Because they produce what? Heat, energy. So a lot of reactions produce energy. That's one sign. Some of them bubble and give off gases. And in some form of precipitate like this one. So here's a precipitate being formed. So those are signs of reaction. Release of energy, something's exothermic. Production of a gas, it stopped bubbling, a gas is produced. And here's a third sign, formation of a precipitate. So one of these products is a precipitate. And so that's not the main function of the lab, but that's what the lab is, precipitate. So in your book there's these rules called solubility rules And if you look at the rules will say chlorides are always soluble, except for a few cases, silver chloride and lead chloride. And then if you look up some of the rules, it says nitrates are always soluble. So this is the solid that was formed. So what do we need to put after it? S, or an arrow going down. So this would be S, and then that is soluble. So what would we put after it if it's soluble? AQ. I'm not going to have you worry about which ones to precipitate. There are rules in the book, you can look them up, but I don't think we need to focus on it because we just want you to be able to write correctly balanced form equations. But these reactions are precipitate reactions, they form a solid. If you want to try identifying which ones to precipitate, just put Google solubility rules or look in the index in the back of your book, and I think it's like page 600 and something. Look up the rules and see if you can figure out, using the rules, you should be able to figure out what the precipitate is. And I'm not going to ask you to do that, but I'll tell you what page it's on. The solubility rules, if you want to, are on page solubility rules. I think it's like 271. On page 271. And then you would see that chlorides are soluble, except silver chloride is one of the insoluble ones. Okay? But I don't want to waste time going over that. You can look over that if you want. I'm not going to ask you to do that. So now, what we have to do is write all the correctly balanced form equations and balance it. And so let me put some of the charges up here. Silver is Ag. Anyone know the charge of silver? +1. Silver, even though it's in the transition element, silver always forms a +1 charge. It's irregular. It only has one valence electron. Nitrate is NO3 -1. Calcium is Ca +2. And you should be able to do this. And chloride is Cl -1. So what's the formula for silver nitrate?
AG.
Yep.
Parentheses, NO2.
3. Nitrate. Yep. It's +1 and -1. What's the formula for calcium chloride?
Ca. Cl.
Cl2. +2 -1 crisscross CaCl2. Silver chloride. +1 -1.
AgCl.
Yep. The ones are easy. Calcium nitrate. +2 -1. And now we need to balance this. But let's pause. Anyone have any question on these formulas? We're just using the ion charge method. And after a while, hopefully you can just do them in your head. All right, who wants to take me through the balancing part?
2.
Yep.
2.
To where?
The first.
Why?
Because 2 NO3.
2 nitrates.
Yeah.
And only 1 nitrate. So you're going to put a 2 here. Yep.
Wait, what?
2 nitrates. Right? 2 nitrates. These are 2. 1 nitrate. Right? Do you understand that? Because nitrates are NO3. There's a 1 here that we don't have to write. just like there's a 1 here that we don't like. So we put a 2 there to give us 2 nitrates. Next, what do you want to do next? Is that it? Not yet. What else do we have to do?
Chloride.
Yeah, chlorides, right? Look, I would start at the beginning. 1 silver, right? We had 1 nitrate, 2 nitrates, so we put the 2 here. That gives us 2 silvers. How many silvers do we have?
1.
So what do we need to do?
2.
2. 1 calcium, and now 2 chlorines, 2 chlorines. There's the correctly balanced form equation.
So what is we for?
What'd you say?
Wait, what? You got the last part. Sorry.
2 chlorines
Yeah.
and 2 chlorines. We're balancing,
So it's balanced.
yeah, the reactant side with the product side. 2 on each side.
Sorry.
That's okay. And there's the correctly balanced form equation. And so we're going to do a lab today, and this is what you're going to pass in. Don't have to do anything, write up or anything. And I'm even going to take away, you can try, you're just going to pass in, actually we're going to look like 6, you're going to pass in 6 of those. You don't need to pass them in today. You're going to write up 6 of these, and that's your lab. You don't need to do this part about identifying the precipitate. If you want to try it, go right ahead. This will be good practice for the test. And so instead of the ones on the lab handout, we're going to do the ones on the other handout. But here's the deal. Right, the other handout, which I just read some copies off of right here. We are going to, I take that back. We're going to do a couple from the handout. Not this handout, the original lab. And I'll just put them on the board. And then if you get them, I want you to do them, and then do this. Right? And then if you get them right, then you're done. You can go. But you're going to stay here till you get them right. So this is what you're gonna pass in. 8 of these 8, right? What you're going to do, don't panic.
I'm already there.
Right? I'm gonna erase this. Is everyone else set?
Yeah.
Okay, so. Right here. I don't want you to keep. You got. Look, all right. Here, that's what we're gonna do then. Silver nitrate. Do that one. But hold on. You're actually going to do it. Okay? So here are the, you're just going to take these chem plates and take some silver nitrate. No. There's 6 of them. So we can have 6 groups. Take some silver nitrate and take some the sodium phosphate. I think I only have. There's only 4 sodium phosphates, but if there are 6 groups, you can just share. You're only going to put a couple drops, and then so you're just going to take the chem plate. I could just do it here, but I'll let you do it. Put a couple drops of the silver nitrate, only a couple, and then put a couple drops of the sodium phosphate, you'll see a precipitate formed, just like we did here. Finish the word equation, write the correctly balanced form equation. If you can do that, bring it up. I'll check it. If you got it and you're good, then you're good. Okay? What you're going to pass in for the lab next week or 2 weeks will be these. You're going to do these on your own. Okay? You don't have to do a lab report. Just do 8 of what we had on the board. 8 of the correctly balanced form equations, just for practice.
So we don't have to do the lab report.
No, this is what you're going to do for the lab.
Aha.
Okay? Alright, so, you can put up some goggles. I know it's only 1 or 2 drops, so here's some stuff up here. But it's okay, put your 2 drops and then bring the chemicals back. So other people can get it. Or share.
Oh, just put it in.
Find some people to work with.
We don't need it. There's none, right?
Actually, how many drops is better? 3?
2 doesn't make a
2.
difference. Doesn't really make a difference.
Anyone want to
Safety
count?
first. Thank you.
Do you have a goggle?
Yeah, I have. Actually, I don't need it. How many goggles do you want?
Oh, you have already?
Yeah, I have.
Okay.
Oh, always. Can we join you all?
Yeah.
Because I have no idea what the hell.
Just put it
Put 2
together.
drops and see the how do you say that word? Precipitation, whatever. Solid or liquid or whatever.
Okay, so
Do I even need these? We don't need these. It's not going to be explosive.
1, 2. Maybe we put more.
He said
You
just a
said 2
couple.
drops.
Yeah, a couple.
What do you call that one? 2 silver night, right? You did it. 1. That's it.
Solid.
It's on the back of this. I know, I didn't know that you said.
You have to mix it?
Yeah, so.
I don't say anything.
Solid.
I cannot tell, only 2 drops. So that's why I only add more because
Yeah.
He said it's cloudy, right?
That's what he said, yeah. It's so solid.
See? So when it is cloudy, like goom, like
yeah,
Yeah.
I can see it.
yeah, it's solid. That means it doesn't dilute. Sodium phosphates. Those are liquid. How is that so?
Chemical reaction.
Anything different?
That's
That's on board.
what is that? The silver phosphate just has a yellow color.
Oh, yeah. Do you see something, Sam? You want to look at it? Yeah, I see some crop. Ugh. I just want to smell it. Hopefully. You smelled it? Yeah. I don't smell like anything. It doesn't smell like anything.
I smell nothing.
Yeah, it smells like nothing. So now we gotta write that out. Write it out? Yeah. So that was the nitrate and what this was it? I want to see the lab.
No, that was it.
X, right?
Sorry. Next time we do this.
That's it. And then what is that? What is I don't even know what that what do you call this formula?
So AB,
Yeah.
It just produces
AYB is AY plus BX. So
it's going to be silver phosphate and sodium nitrate.
That means why? Yes.
It's a negative. You don't want to keep the plus one and the negative. Well,
So we're supposed to do all of them? 1, 2, 3. There's one?
Doing this one and then you bring it up, I need to check it. Yep, that's fine, but I need to check your answer.
Oh,
I'm checking your answer. That's your exit ticket.
So do we write it?
The first one stays the same.
Now balance it, yep.
And then PO4 is minus 3, Na3,
Yep.
Na3, PO.
Ionic compounds. We use the prefixes only for the covalent compounds.
and
Yeah. Right here. What are you looking for?
no, the other question.
So,
Nitrate and
You're ahead of us.
NO3, yes.
Yeah, so the ending of a non-metal in a compound is changed to IDE.
so
Na3.
No, all of them.
Because
Bromide,
it's phosphate, right?
iodide,
Yeah.
these
And
phosphide,
so it's Na3.
sulfide,
That's
these ones
phosphate
here are changed to
PO4.
IDE.
You drop the one.
Oh.
That's a one.
Anything that ends in, yeah.
Doesn't have the minus. Which one?
Well, actually, all of
This
them
one,
changed,
it
it's
doesn't
changed to
have
IDE, not these,
Oh, you
these
create
no
Different
gas.
process, so now it's
Okay.
what, sodium 3, phosphate, okay?
No, these are all, you need, change the end, if you have a compound, right? With a metal and a non-metal,
Yes, it is.
the non-metal name is changed to
I thought you meant
IDE.
phosphate is a phosphorus thing. So let me look
Yeah,
at, I don't know
oxide,
about the top of my head.
nitride, phosphide, sulfide,
Phosphorus is
fluoride,
negative.
Yo,
Yeah, the charge.
and chloride, bromide,
3.
selenide, iodide,
There, it's
all
like, wait a minute,
those
where are you
are
getting
the
so the thing
non.
the bottom
PO,
of
it's 4, yeah.
I don't think there's such a list.
I know, but I want to. They can explain it.
And sodium and.
So
You know what you can do, let me show
You better
me
stop
the
being
book.
stubborn.
Take the book.
It's not gonna
Yeah.
work.
Because I wrote about if I start on the past, I would think it's
Yeah.
And S3.
So,
Some in S3.
when you look at these ions, let me see.
And then convert it.
So here are some
So
common
it
ions.
comes NaO, Na3, and O.
Right here, here's some, here are the ones right here.
Because he was saying we can look in the
So
book.
we have sodium, Na. And then nitrate is NO3, right?
You have to write the formula with everything,
Nitrate.
and you're balancing, right?
Isn't that the silver?
Yeah, with silver nitrate.
NO3.
You're balancing this side, the reactant side, against the product
So I have to
side.
do it up here as well.
Yeah, that's why I try to keep them on one line when you react that, but this is the reactant side on the left, and then you gotta balance it with the product side. Where did you get this? It's phosphate.
That was phosphorus.
No,
Oh, no.
phosphate, you're gonna usually
Nitrate
try to
is negative
polyatomic
1.
ions.
So I was
The
wrong.
electric charge.
Yeah.
I'm sorry.
No, it's not.
So
So
it's just
what
NaNO.
Oh, this one, this chart.
First, finish the word equation, right?
Yeah, I'll do that up top.
And then write the formulas for everything. All of them. Not just half of them, but all of them.
Yeah, but
On
this
both
one's
sides.
NaNO3. Is that okay?
No, I don't see it on there.
4.
Okay, now you need to balance it.
Alright, so now we have,
Let us start with this one.
which one? The nitrate?
S3.
Here, copy from hers. We already checked it.
I think I'm done.
Oh, okay.
Yeah.
Okay. Okay. This is NO and NA. NA, right?
Done.
Na.
Okay.
Sodium. What did you balance out?
Did you balance that?
So he got the silver.
Yeah.
So we have
No, no,
3 here.
I teach you how
So
to do
we
it.
have 3 silver here,
Because
right?
we have 3 silver,
Okay.
so we put 3 here.
Because you only have 1 on this side.
3. Okay.
So now, and we have 3 nitrate.
Yeah, because we have 3 that one, so we have 3 here. So we put 3 here.
Oh,
Okay. What about
You have to put 3 here first. So
A?
we already have.
Yeah,
So
it's
that's it.
balanced. That's it?
Yeah, that's it.
And S3 and S3. Oh yeah. Can you? Well, unless.
Done.
You want,
So basically,
Yeah, the left, yeah, do
Yes.
those.
the
Just
left,
like that, that's what, you have to pass in 8 of those from that second sheet.
do you want to show me and show you
Yeah,
my?
you got the same thing?
Yeah, we are together.
No left, right up, no. Just, yep. No, this is chapters 3, 4, and the beginning of 5. 3, 4, and the section 5, and chapter 5, the first couple of sections.
I wonder if it's on the back of it.
Yeah.
Oh, negative.
Well, I mean, you can try emailing me, but you look at the practice test. My email's online. Look at the practice test, right? This thing here, and check your work with the, see if you can figure out.
Sodium is a positive. Is positive.
Make sure you're looking at this. Check your work on the back. And if you don't get it right, see if you can figure it out. Okay.
Do it this one very well.
Yep. And then here's the same thing. Here's the answers on the back. So start with this and check your work. And then if you didn't get it right, see if you can figure out what you did wrong. And we'll go over this if you have any questions before. What? I don't have office. Yeah.
All done.
Done, right?
Just like
Bad,
this,
right?
you have to do that.
Good, right?
Yeah, the same thing.
Yeah, a little bit I confused about just
So
I don't
you should
yeah.
put the make a list and put the charges first. That way you won't get confused.
Yeah. First,
Yes.
this one.
Yes, and make sure you put the charge.
Last time I made very different way.